if you're like me, you're like, okay, I'm working with this area, but it's still, I don't know, it's still not like this L shape. It hasn't yet been broken down into something that I can work with, okay? These quadrants, like if you can think of a shape that's close to one of these quadrants, what do you think it's closest to? What do you think?
Triangle.
Ooh, okay, so as a whole, right, I think this does kind of look like a parallelogram. You can sort of see the parallel sides. Each individual quadrant is a triangle, right? Or it's close to a triangle. Can you see? I could put like a shape like this. That looks pretty close to my quadrant, doesn't it? It's not exactly. It's kind of off a little bit, but it's on the right track. Okay. So now, I'm going to try and do this, but I'm going to try and do it better. We've got a new circle here, okay? Instead of just taking the halves and halving them, I'm going to take the halves and I'm going to divide them into more smaller sections like this. Okay, so now I've got a pizza, okay? I've got 8 slices, okay? And when I reassemble, I'm going to skip this step, but I would like you to draw it. You can see I'm getting something that's starting to look a little different, right? Do you agree? It's still the same area, right? Still the same area, still the same size, but I've rearranged it a bit, haven't I? Let's have a look closely at this. All right, here we go. Ta-da. Okay. So you see what's happening, right? Earlier on, Adam mentioned the whole shape, the whole shape that I've got here, it kind of looks a bit like a parallelogram. Do you see that, right? Look, I've got 2 sides here that really are parallel. You get a ruler or a compass out and check. And then this guy here, it's almost like a straight line, isn't it? It's like a bumpy straight line, okay? So, can you imagine I had 4 sectors first, then I had 8. What do you think I'm going to do next? I'm going to go again. I'm going to take this guy, right? And I'm going to divide it up. This is about as practically far as we can go in here. Divide, 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 divide. Okay, this is starting to get messy. Here we go. 1, 2, 3, 4. There you go. Okay, that's a lot of sections. Okay, that's a lot of sections. What's it starting to look like? All right. Here's what I've got. Here's what I've got. Okay. Now, I've run out of blue tack. Here it is. Okay. What we're doing here is we are approaching a particular kind of shape, right? It's getting more and more like a shape that we actually know the area of. Okay. Whoops, that's a bit too high. Let's move it up. Okay. This is not only approaching a parallelogram, right? It's getting really close, isn't it? But can you see, like, see this edge of the parallelogram? Each time I go along, okay? Can you see the edge is actually changing subtly? Like, see, this one's like way off at an angle. It's really leaning over, right? And then this one is leaning over, but only a little bit. And then this one is getting closer and closer to standing up straight. Yeah, and what were you gonna say? Yeah, good. You can see if I went, so wait, let's do one more. You already drew 3 circles. Let's draw a 4th one. Here we go. Now, if it were possible to divide up this circle into an infinite number of pieces, right? What have I left out? Here we go.
So how could you, because eventually there'd be no more space.
Okay, well, like you can see, it's like I'm getting pieces that are kind of chunky to less chunky to now they're getting thin, and they'll get thinner and thinner and thinner. They'll get very, very thin, but they'll never be nothing. Like I've still got an actual circle, right? But what happens when I rearrange the shape? Well, what's it going to look like? It's going to look something like this.
Yeah.
Right? Isn't it going to look like this, where I have all these really, really thin slices, right? It's like trying to share a pizza with like 1,000 people. And it's like, okay, you all get this tiny little sliver, okay? If you put all the slivers end to end, you would get this rectangle. Okay? Yes?
But Wouldn't it still have the slightest bit of a curve?
Okay, so here's this amazing thing, right? If we actually had, like, if we kept doing this with actual paper, yes, there would always be like this bumpy. It'll just be a little bit bumpy. Or you can see even my lines are bumpy, right? But as mathematicians, we can do more than just imagine like an actual piece of paper. We can take that circle into our minds and we can do it. So there's really not just a lot of slices, we can imagine an infinite number of slices that are all infinitesimally thin. You can't do that in real life, but you can do it in your mind. Mathematically, we can do it. Okay. So here comes the most powerful step. Here we go. Okay. I need another color. Here we go. You told me right at the start of this lesson, right, that the circumference of a circle is 2 pi r. Do you agree with that? 2 pi r. Okay. So come over to my orange and black circle here. If the whole circumference is 2 pi r, what is this distance here? Just that distance there. It's going to be, yeah, I think I heard it. It's going to be pi r, right? It's not 2 pi r, it's half of that. Because I've got half the circle. It's pi r. In the same way, what about this part of the black circle? It's also going to be pi r, right? So when I come down here, can you see that this curved part, that long curved arc, over here became this guy? Whoop. Can you see that? That curve became this curve, right? It's still the same length, isn't it? Like it's the same shape, literally just cut into pieces, right? All right, come up here, right? This green one is exactly the same as the orange one. It is also pi r. Okay? Where's that green pi r? Where is it here? Yeah. Very good. It's here. Whoop, 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 whoop. There we go. There's pi r. Okay? I don't need to keep going up here, do I? What's it going to be down here? I've got this guy. Pi r. Starts off really, really wiggly. A bit less wiggly. Not very wiggly at all. Once I get to this special case, because it's infinite, it's a straight line. And it's still pi r. Pi r. Okay, now we're trying to work out an area, right? It's a rectangle. What else will we need to work out the area of this rectangle? Yeah, Brandon. We need a length, right? We've got a width, a breadth, and we want this thing. We want this thing. Now, I wonder if you can help me work out what it is. Have a look at our shapes, right?
Is this the radius?
Yeah, Daniel, what do you think?
I was going to say, wouldn't it be the radius from the center?
It's going to be the radius. Now, how can we see that? Have a look at how we cut it. It's this straight edge, isn't it?
Yeah.
And this straight edge, and this straight edge, and they're all coming from the center of the circle, right, out to the circumference. And they're all the radius. Okay? So therefore, radius. Okay? I'm almost there. I want an area, right? What's the area of a rectangle again? It's length times breadth. R times pi r. Pi r
Which is the
squared.
same as the circumference.
Almost. It's so very close, isn't it? There's still a pi, there's still an r, but the 2's out the front here,
Oh.
and the 2's up here. Okay? Now, there's a really easy way to remember which one's which, because they look so similar, don't they? They look very similar. Okay. That's an area. That's a length. When you're doing a length, right, it's like something like centimeters, or meters, or kilometers, right? When you do an area, what units do you use? You might use centimeters squared, or meters squared, or if it's a really big circle, kilometers squared. All areas are in square units. So that's why the area of a circle has the square in it, right? Whereas the circumference does not. Still has a 2, but it's in a completely different spot. All right?